solve the following Bernoulli's equation. Okay, here is the standard form of Bernoulli's equation: y prime dy over dx plus function of x y qx y to the n. Due to the presence of y to the n, this is a non-linear equation. Okay, let's try to put this into the standard form. So this is dy over dx equals, let's distribute y, we get x y to the fourth minus y, and let's move y to the left side. So dy over dx plus y equals x to y to the fourth. Okay, and here is this is y prime plus 1y, the px. If you want to compare with this standard form, px is 1 and qx is x and yn is y to the fourth. Due to this term, this factor y to the fourth, this is non-linear, and we can say this is, let's say, n equals 4 in this case. N equals 4. Now we make a substitution. V equals y to the 1 minus n. So v equals 1 so we make v equals y 1 minus 4, which is y to the negative 3. We make this substitution, and that substitution, this substitution will change this non-linear into linear. Okay, this substitution can be assumed in this way. What I would do, I would leave only function of x in the right hand side. For that, divide by y to the fourth, divide both sides by y to the fourth, just to leave a function of x in the right hand side. So 1 over y fourth dy over dx plus divide by y to the fourth y over y fourth, so y to the negative 3 equals x, and this is the v we were talking about earlier. Okay, so let v be y to the negative 3, and then take the derivatives of both sides with respect to x. Then dv over dx is yn, power rule, n y n minus 1 times derivative of y dy over dx. Now with this substitution, this equation becomes, let me write over here, and for future reference we could say this is star. Okay, then the equation star becomes 1 over y to the fourth times dy over dx. Okay, we are supposed to solve for dy over dx. Let's go back here and solve for dy over dx. dy over dx is equal to, move this to the left, that means basically divide, so negative 1/3 y to the negative fourth on the bottom, which is same as y fourth on the top, dv over dx. Okay, and dy over dx is negative 1/3 y to the fourth dv over dx plus y to the negative 3, this is v, equals x. Let's simplify this. Y fourth cancel, and negative 1/3 dv over dx plus v equals 3 is negative 1/3. Let's move this, let's get rid of this and just leave dv over dx. For that we need to multiply through by negative 3. Okay, negative 3 cancel, so this is dv over dx minus 3v equals negative 3x, and this is a linear differential equation in v with respect to x, linear in v. And we've seen how to solve linear equations. Okay, linear in v. So we find integrating factor mu x, that's e raised to, that's negative 3, that's the coefficient of v, so negative 3 dx e raised to negative 3x. Now we multiply this linear, let's say star double star, multiply this linear equation by integrating factor, multiply this linear by integrating factor, we get the left hand side becomes derivative of the dependent variable v and the integrating factor e to the negative 3x. Right hand side, let's multiply negative 3x by e to the negative 3x. Okay, now we integrate both sides with respect to x. Then this is just v times e raised to negative 3x is equal to negative 3 can be pulled outside, x times e raised to negative 3x dx. Okay, so we have a product of two functions, and derivative of negative 3x is negative 3, but we have x, so u substitution does not work. Now it's the product of two functions, so we need to use integration by parts. Okay, so we find this integral by integration by parts. Okay, let's do that in separate. So integration by parts here, so let me do over here. So we have x times e to the negative 3x dx. So let u be x and dv, the remaining e to the negative 3x dx. So du is derivative of x is 1 dx, integrate v equals antiderivative of exponential function is itself. Now we need to divide by this factor negative 3. Okay, and we use the fact that u dv equals u v minus v du. That's the integration by parts. So that is now u v, u times v, so negative 1/3 x e to the negative 3x minus v times du, v times minus, and this minus plus is 1/3 e to the negative 3x dx. So this is negative 1/3 x e to the negative 3x plus, let's integrate this, 1/3 times antiderivative of e to the negative 3x is itself divided by negative 3, this factor, which comes by the way from u substitution. Okay, so let's go back here. So this is v times e raised to negative 3x equals negative 3 times everything times negative 1/3 x e to the negative 3x plus this plus and is minus 1/9. So minus 1/9 e to the negative 3x and plus c. Okay, we can write outside this constant of integration plus c. Let's simplify. So v times e to the negative 3x equals, let's distribute negative 3, negative negative positive 3 cancel, so x e to the negative 3x, negative negative positive 3 divides 9 3 times, 1/3 e to the negative 3x plus c. Now divide by e raised to negative 3x, so v equals, divide by this, cancel, so x plus cancel 1/3 plus is a c, divided by this, so c e 3x. Okay, now we replace v by, what is v by the way, go back, v was y to the negative 3, 1 over y cubed. Let's substitute that and we have the answer. So v is 1 over y cubed equals x plus 1/3 plus c e to the e raised to 3x. In fact, You can combine these three fractions and take reciprocal, so that you will have y cubed equals something, and take cube root. That would be explicit answer, but this also works. This is implicit solution. Final.